The directions say to determine whether the series, and it's the summation from n equal 1 to infinity of 1 times 3 times 5 all the way through until 2n minus 1, divided by 3 times 6 times 9 all the way through until 3n, times negative 3 halves to the n converges or diverges. Now, I want to address the denominator. Notice that 3 times 6 times 9 all the way through until 3n can be written as follows. And so 3 is equal to 3 times 1. 6 is equal to 3 times 2. 9 is equal to 3 times 3. So I'm going to continue in that pattern until I stop at 3n right here. Okay? Notice how I have a 3 in the first spot, a 3 in the second spot, a 3 in the third spot. Essentially, I have n copies of 3 being multiplied together. And so I can rewrite this as 3 to the n times 1 times 3 times 4 all the way through until n. And that's the last line here. Okay. So this series can be rewritten as follows. And so this is the summation from n equal 1 to infinity of 1 times 3 times 5 all the way through until 2n minus 1 divided by 3 to the n times 1 times 2 times 3 all the way through until n times the quantity 3 to the n over 2 to the n times negative 1 to the n. The 3 to the n's are going to cancel. And what we have left is the summation from n equal 1 to infinity of 1 times 3 times 5 all the way through until 2n minus 1 divided by 2 times 4 times 6 all the way through until 2n. And that's multiplied by negative 1 to the n. And so we're going to look at the alternating series test. So a sub n is equal to 1 times 3 times 5 all the way through until 2n minus 1 divided by 2 times 4 times 6 all the way through until 2n. Now, one thing I want you to notice is notice how this a sub n is strictly greater than 0 as long as n is greater than or equal to 1, right? That's important because now I'm going to look at a sub n plus 1. Notice how I get 1 times 3 times 5 all the way through until 2n minus 1 times 2n plus 1 divided by 2 times 4 times 6 all the way through until 2n and then times 2n plus 2. And so one thing I want you to notice is I took a sub n plus 1 and I wrote it as follows. I took a sub n, which we've already argued is greater than 0, and I multiplied it by something less than 1. Okay? So I multiplied it by 2n plus 1 over 2n plus 2. Okay? That's less than 1, which says that this is less than a sub n. Okay? Let me give you maybe some numbers to help drive home this point. If I take 2/3 and I multiply it by a number less than 1, and so I'm going to use 3/4, I claim that that's strictly less than 2/3. It is. Because 2/3 times 3/4 is 1/2. And 1/2 is most certainly less than 2/3. And that's the idea here. So a sub n plus 1 is less than a sub n for n greater than or equal to 1. And so what that tells me is that the sequence a sub n is decreasing and bounded below by 0. And so the limit as n goes to infinity of a sub n must equal 0. It's another way to say that the sequence converges to 0. And so the summation from n equal 1 to infinity of negative 1 to the n times 1 times 3 times 5 all the way through until 2n minus 1 divided by 2 times 4 times 6 all the way through until 2n. This must converge by the alternating series test. And so that says the original series, and that's the summation from n equal 1 to infinity of 1 times 3 times 5 all the way through until 2n minus 1, divided by 3 times 6 times 9 all the way through until 3n, times negative 3 halves to the n, converges by the alternating series test, because those are equivalent series. And that's going to conclude this video. Okay, thank you.